In this video, we will provide a brief introduction to what Yocto is, and we will analyze the Microchip Yocto layer. The Yocto project is an open-source collaboration project that helps developers create custom Linux-based systems that are designed for embedded products, regardless of the product's hardware architecture. For a very basic Yocto introduction, we suggest you have a look at this short introductory video or consult the official Yocto homepage. Yocto's layered structure allows you to have an architecture-agnostic system that can be enriched with hardware-specific support. The Microchip BSP layer will add on top all necessary recipes to instrument the build for the Icicle kit with some platform-specific configurations that may be further customized to fit user needs. The bottom layer is the Open Embedded that provides support for QEMU emulated machines, together with Meta Open Embedded that adds some additional support. On top of that, we have the Meta RISC-V layer for RISC-V architecture support. On the upper level, we find the Meta PolarFire SoC Yocto BSP layer that includes all needed recipes to build for our specific platform as the bootloaders. The user may add his own layer for application or driver-specific code. The build is controlled by an executable called bitbake, which is responsible for processing the dependencies and scheduling the tasks using an input to the recipes provided in metadata layers. Tasks typically involve fetching sources, configuration, cross-compilation, and installation on the target file system. Tasks are executed as far as possible in parallel based on the number of processors available. Microchip provides a GitHub page for PolarFire SoC-related material. For an extensive description of the GitHub page, please watch the video linked in the description below. Here we can find the Microchip PolarFire SoC BSP layer. Let's start setting up the build system. Typically, Yocto layers can be part of different Get projects, so a tool like Repo can be useful. Repo is a Python script that helps in handling multiple independent Get repositories related to the same project. Hence, we are not cloning the repository directly, but we leave this job to the Repo tool. So our first step will be to install the repo. Let's download the Repo script. We then make it executable. We can then move it to our favorite program or bin folder and add that folder to the path. In order to test if Repo has been correctly installed, we can type repo-help. Once we have Repo ready, we can use it to fetch the sources. Let's create our Yocto main folder and move into it. Now we can initialize Repo by using the repo init command. With this command, we are asking Repo to fetch all the layer repositories defined in RISC-V Yocto.xml file, the ones required to build a generic RISC-V machine, plus the Microchip BSP from master branch that adds support for the Icicle kit. This process creates a hidden .repo folder. Now we can sync with Repo. With Repo Sync, we actually clone the repositories if we are doing this operation for the first time. Otherwise, we update them with the current version. Let's have a look at the folder structure. We can see the main layers we described before: Open Embedded Core, Meta Open Embedded, Meta RISC-V, and Microchip BSP, Meta PolarFire SoC Yocto BSP. We can also inspect the content of the Meta PolarFire Yocto BSP. In the Recipe BSP folder, there are recipes that control the bootloader build. Inside the Recipe Kernel folder is the recipe that handles the Linux build, and some patches required for PolarFire SoC. In the Recipe Core folder, there are some recipes that control our particular image feeders. We can also see that there is a script called PolarFire SoC _Yocto setup.sh. This is the setup script. Typically in Yocto Flow, we need to source the Open Embedded init build environment, add the layers that we want to use, and customize the configuration file that is created by the script. All these actions are accomplished for us by our script, as we can see by analyzing the code. Now we are almost ready for building. We will analyze this process in the next video.